finding a ratio. So possibly a tangent ratio, possibly a sine ratio, maybe a cosine ratio, just whatever they're asking for. So we're going to practice first just making ratios, because that's very important for solving for the problems. But right now it's just setting up a ratio to practice, if you're using tangent, what are you setting up, if you're using sine and all of that, and then labeling your sides. So if I'm talking about finding the ratio for tangent A, then I'm talking about angle A. And remember, the phrase, so some old horse caught another horse taking oats away. The tangent ratio is this one with the T. So opposite over adjacent is the ratio for tangent all the time. So across from A, the opposite from A would be the side that is not part of A. See how this side and this side create angle A. So the opposite one is the side that is not a part of creating that angle. So the opposite is where the 45 is. And then I need the adjacent. Well, this is the hypotenuse out here, and over here would be the adjacent side. So for the tangent of A, if I'm just writing a ratio, it would be the opposite over the adjacent. And that's just setting up the ratio that represents tangent of A. And later we'll actually use this ratio to find the angle that is A. So the ratio is very helpful. At this point, though, we're just using it for practice. So it also asks for finding the tangent of B. Now the tangent of B is going to be different, and your sides are going to be different. So I'm going to use a different color for this. Opposite from B, the side that does not help to create B, is the 28. So for this one, 28 is the opposite. Hypotenuse is still the hypotenuse, and the 45 would be the adjacent side. So for the tangent of B, it would be the opposite, which is 28 over 45. And notice they're reciprocals of each other. And that will always happen with tangents of these angles, that will happen. This second set here is talking about the sine ratio. Let me see if I can bring this all downward. Oh, there's the sine. So the sine ratio, opposite over hypotenuse is the sine ratio. So if I'm finding the sine of R, well, here's R. Opposite from R is 15. The hypotenuse would be 25. I need O and H, just opposite and hypotenuse. So the sine of R, the sine ratio of R, is the opposite over hypotenuse, so 15 over 25. And I didn't do this on the previous one, you would reduce it if at all possible. And sometimes they may ask you for it as a decimal. It just depends on what the question is asking you to do. I'm going to reduce it. So this both of them will divide by 5 and would reduce to 3/5. So the sine of R is 3/5. You do want to reduce it if possible. And then they also wanted us to find the sine of S. Here is S. In relation to S, opposite from S would be the 20. And the hypotenuse is still 25. So for the sine of S, it's opposite 20 over hypotenuse 25, and that will reduce as well. So the sine of S, dividing both of those by 5, is 4/5. That would be the sine ratio for S. On the bottom here we have the cosine. Cosine of A. Cosine caught another horse. Cosine is adjacent over hypotenuse. So label your hypotenuse. Opposite from A, that'd be the opposite. So here is the adjacent. So adjacent to A is the 48. So the cosine of A would be the adjacent side, 48, over the hypotenuse, 52. And then you need to see if that reduces. So 48 and 52 would reduce to Dividing them by 4 would be 12 over 13. So the cosine of A would reduce to 12 over 13. And then for the cosine of B, so here's B. Opposite from B would be this one. Adjacent to B would be this one. The hypotenuse would still be the hypotenuse. So adjacent over hypotenuse, and I think that's a 20. Yep. So the adjacent side is a 20, so the cosine of B, adjacent to B is 20, over hypotenuse is 52. And so 20 divided by 52, reducing both of those by 4, would be 5 over 13. So the cosine of B would be 5 over 13 if you reduced it. So that's how you set up your just a general trig ratio, just setting it up. What we would use that for later is to find the angle. We'll be setting up these ratios a lot, but generally one of the sides that will be in this ratio, we will not know what that side is. And we'll be using the angle, because we'll actually know the angle for those when we're finding the side. But this would be very good for actually finding the missing angle, and that we'll do later.